Assalamu alaikum. Welcome to my class. This is Muhammad Rafiqul Islam, lecturer of mathematics, Public School and College, Saidpur. Today I'll discuss about function and its graphs. First I'll discuss about relation. Let us consider two sets. A 1, 2, 3 and B another set. The element of it, suppose here 2, 4. So the Cartesian cross product of A and B 1, 2, 3, 2, 4, we get 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, 3, 4. This is the A cross B, or we can write here the subset of A cross B. 1, 4, 3, 4, right here 3, 2, R2. Suppose I am writing 2, 2, 3, 4, R3. It may be any one, 3, 2. We are seeing here R1, R2 and R3. These three are subsets of A cross B, that is R. Here R, R1, R2, R3 all are relation from the set A to set B. So what is the definition of relation? If A and B are two set, the Cartesian cross product A cross B and its non-empty subset is called relation the set A to the set B. Here R, R1, R2, R3, this is the relation of the set A to be the set B. Now the domain of the relation, suppose I am finding domain of the relation, that is A cross B. We can write here DOMAR in short name. This will be 1, 2, 3, and range of R, this will be 2, 4, and inverse relation of A cross B, that is R, is denoted by R inverse. This is inverse of R. Domain will be range and range will be domain. This is where 2, 1, 4, 1, 2, 2, 4, 2, 2, 3, 2, and 4, 3. This is the R inverse. Now I'll discuss what is the function. I'll discuss taking the definition of relation. If first element of order pair for every time is different, the relation will be function. I am giving one example. Function. Suppose A, the element of it 1, 2 and B 3, 4. If we write here A cross B, then we get 1, 3, 1, 4, 2, 3, and 2, 4. You know, this is also relation. Here 1, 3, this is the ordered pair, 1 minus 4, 2, 3, and 2, 4. All four are ordered pair. If the first element of every ordered pair is different, then the relation will be function. But we are seeing here first two element whose first element is same and last two element whose two first element is also same. If we have to make this relation function, we can write 1, 3, 2, 4, because here first element of ordered pair, this ordered pair here 1, and first element of ordered pair of second, this element here 2. These two are same. This is the function. Also it may be 1, 3, 2, 3. This is also function. First element is defined. Since here second element is same, no problem there. Here f1, f2, these are the function. We can define another way. Definition of function. Suppose here A is the set and B be another set. The element of A, B, C, and element of B, suppose 3, 2, 4. This is the function. We can write this f such that A tends to B. So f, this will be A 3, B 3, C 2. This is the function. If we write here B, A, B, C, 1, 2, 3. So we are seeing here if, suppose we mention this is the set F, this will be A, 2 or A, 3, B, 1 and C, 3. This is not a function because here first element is same. This is not a function. Not a function. This is the function. So what is the important things? If you have to define function, the first element of ordered pair will be different. Then the relation will be function. If first element of one or more ordered pair is same, this will not be a function. Now I'll give another definition of function using two variables. Suppose x and y be two variables. Suppose x and y are two variables. For every value of x, will have distant value of y, then y is called function of x. It is generally denoted by y is equal to g of x or h of x or f of x or phi of x, etc. Suppose I am writing here y is equal to 3x plus 1, y is equal to 4x minus 1. These two are example of function. Or function. But if we write here square root, this is not a function. Not a function. Because if we write here x is equal to 1, then we get here y is equal to square root 3 1, that is plus minus 2. For one value of x we get two value of y. This is not a function, because if we write in the form of ordered pair, we get here, suppose 1 is domain, then we get here 1 2 1 minus 2. Here ordered pair is same, so this is not a function. Now I will discuss domain and range of a function. Domain and range. First I will discuss domain. The set of all values of x, if we put of a function, we get a different values of y, then the set of all value of x is called domain of the function. Suppose y is equal to 3x minus 5. If x is equal to 1, then we get here minus 2, x is equal to 2, here 1, x is equal to 3, so here 1 2 3, and b minus 2 1 4. This is the function. We can define here f such that a tends to b. Here f of x, this will be 3x minus 1. This is the function, and domain of this function will be 1 2 3, here 1 2 3. So what is the range of this function? By putting every value of x, we get different value of y. The values of y is called range of the function. That is, the set of all input of the function is called domain, and the set of all output of the function is called range. Here range of this function, this will be minus 2 1 4. Range of this function here minus 2 1 4, and domain of this function here 1 2 3. Now I'll discuss codomain. Codomain suppose f such that a tends to b is a function here A is domain and B is codomain of this function. Codomain of the above function. Suppose I am defining thus f such that A tends to B is a function. The element of A here A, B, C, and element of B here 1, 2, 3, 4. Here domain A, B, C, codomain 1, 2, 3, 4. Events 1, 2, 3. Because here the image of A here 1, image of B here 3, image of C here 2. So image will be the range of this function, and here A, B, C, this is the domain of this function. Now I will discuss different types of function. First I will discuss one-on function. If f such that A tends to B, be a function, f is called an one-on function for each value of set A have distinct image in B. Suppose is the set A, X, Y, and B be another set, the element of suppose 10, 12, and 20. If we write this, the set A was every element have a distinct image in B. This is the one-on function. This is the one-on function. Or if x1 and x2 domain for different value of x1 and x2, if f of x1 is not equal to x2, then we can tell the function is one-on function. That is, if we put here f of x1 is equal to f of x2, we get x1 is equal to x2. This will be one-on function. Now on to function. On to function. If A tends to be be a onto function if f of a is equal to b. That is, range of this function is equal to the codomain. So here x, y, z and b be another set 1, 2, 3. Here we are seeing here domain x, y, z, range here 1, 2, 3 and codomain also 1, 2, 3. Since range and codomain is equal, so the function is onto function. This is the onto function. If the codomain is equal to the range of the function, then the function will be onto function. Now, identity function. Identity function. If such that a tends to a is called identity function if and only if f of x is equal to x. That is, range and domain will be same. Suppose here f of x is equal to x. If we put here x is equal to 1, f of 1 we get 1, x is equal to 2 and x is equal to suppose 10, then we get here 10. So we are seeing here domain 1 to 10 and range is also 1 to 10. This is the identity function. Constant function. Constant function. If such that a tends to b is called constant function if for every value of set A has same image in B. For example, f of x is equal to 10. We can write this 10 plus 0 into x. If we put 0, this is the 10, minus 1, this also 10. So here domain 0 minus 1 and range only 10. This is the constant function. I'll discuss now composite function or product function. Composite function. two or more functions is called composite function. Uses output of one function will be input another. Suppose that A is the set, the element of it x1, y1 and z1. B be another set, the element of B here x2, y2 and z2. That f is the function from A to B, and from B to C another function. This is the G function, x3, y3 and z3. Conversely, this function f of g such that a tends to b will be the composite function. Here A, B, C are two non-empty set. The function f such that a tends to b and function g such that b tends to c is defined composite function f o g such that a tends to c. Now inverse function. Inverse function, suppose f such that a tends to be a function the inverse function is defined as f inverse b tends to a. Suppose I am giving one example, f of x is equal to x plus 1. The inverse function of f of x, this will be, we can find y is equal to f of x is equal to x plus 1. That is f of x is equal to y, or x is equal to f plus y, and y is equal to x plus 1, or x, this will be y minus 1. We know x here, f inverse function, the variable which may be changed by replacing y by x, we get here f inverse x, x minus 1. So the inverse function of f of x is equal to x plus 1 is x minus 1. Thanks for watching my class. Stay home, stay safe.